So before that, did you guys have any questions about the previous homework and lecture? Please let me know if you have any issues with the homework or anything before we start today's class. Any questions, everybody? All right, so let's talk about rational equations. It's basically, let's first define them. Definition of rational expressions or rational equations. It's basically an equation with an equal sign, right? And there is some rational expression here, some maybe another one here. For instance, 1 over x plus, let's say, 2/3 over maybe 4 over 5x. Okay, so that's an example of a rational equation. It's a little unfamiliar with the previous, because the previous equations we learned the x wasn't here, x usually here at the top. But the methods of solving this and the other type of first degree equations is the same. There's another one, you may get something like this. Say x minus 3 plus 1 over, let's say x to the second minus 9. And okay, that's another type, you see. Kind of looks a little unusual or a little complex, but it's not really that complex to solve, as we're going to see. There's a couple of steps that we do here. Similar to, so these are rational equations. Again, why we call them rational? Because they have rational expressions for these fractions with polynomials, top, bottom, there's polynomials here, p over q, something like that. And they're quite similar, and at least in the methods we solve them to first degree equations. If you remember, we did something like this in the beginning of this semester. So let's say you had x over 5 plus maybe 2x over 3, and maybe 1/3. Okay, so this is a first degree equation. It's not a rational equation because, as you can see, the x is here at the top, not in the denominator. So this one here kind of looks like this. They're both equations, but this one is first degree, this one is rational. It may turn into a first degree later. We're gonna, after we do a couple of steps. But you can see we have the x in the denominator, so that's what makes it rational.
Hello, everybody.
Because it has polynomials. There's a monomial here, and here we have a binomial. It could be trinomial, it could be anything, as we saw before with the rational expressions. So let's first review how to solve this, because the method is quite similar to this. Okay, so no need to panic or when you see something like this. So again, quite similar to this. So let's start with this. Start with solving this. What do you do again to solve this kind of equation? Remember what we did in the first term this semester. What is the first thing you do, first step?
What is what?
Factor?
No.
Okay,
This is not a rational equation. We just trying to review what we do with equations with fractions like this, as we did in the beginning of this semester. Not rational expressions yet, just review the method of this. What do you find first? Or how do you get rid of all these denominators?
simple.
We need
They have to have the same.
Find
the greater common factor.
Okay, we're just gonna move, right? The 1/3 to the left.
There's a better way of canceling out all these fractions at the same time. But to do that, we need to find something.
The greater common factor.
Not common factor, but We're talking about the denominators. What is it that we
So,
find?
The
50,
common
no,
denominator.
The common denominator, that's right, the LCD. So whenever you see an equation with more than two fractions, if you have just two, you can just cross multiply. But if you have more than two, we can find the LCD in order to get rid of all these fractions at the same time. So first you want to find LCD.
It's gonna be the 15.
That's right,
15.
exactly. So the LCD there will be 15, 5, 3, and 3. And once you find the LCD, what do you do with it?
The same thing you do with the bottom, you do on the top.
Okay, or we can multiply. Okay, multiply all by LCD. Just find your LCD, in this case is 15. To that LCD, just write it next to each fraction, as if you were to multiply, but we're not gonna multiply yet. Okay, each one of these fractions will all be multiplied by that. Now that we put the LCD next to each one, what happens next? So we're not multiplying yet. Instead, what do? You want to get rid of these fractions. So how do you do that? You can just simplify first. So before multiplying, we're going to simplify here. So we have 12. Actually, the LCD is not, should be 15. Okay, that's what we said the LCD was. Okay, so take that LCD, whatever it is, basically just...
Sorry, Professor. I don't understand. Why you just put 12?
By mistake.
Oh, okay.
Okay, so it should be 15, 15, and 15. Okay, so you take your LCD and just put it next to each fraction. Now we just reduce. So before multiplying, for example, 15 and 2, we can actually reduce to get rid of the fraction. So this and this cancels out, so we have 3x. Same thing here, so 15 by 3. So again, before multiplying with the fractions as we saw before, you want to simplify them first. So 15 by 3 will be 5. And you bring down whatever this number is, so times there 2x. And same thing here, so 15 simplify will be just 1, 5 times 1. Now we can go ahead and multiply. So the multiplication we talked about earlier here. Okay, so now we can do the actual multiplication. So that's 3x plus 10x and 5. As you can see, once you get rid of all the fractions, see, the equation becomes a lot simpler and easier to solve. The rest now is easy. We're just going to combine like terms and solve. So this is 13x and 5. And what's the final step here to solve this equation? Everybody, what is the last step in this?
X 5 over 13.
So we divide both sides by 13. Finally, x is
5
5
over 13.
That's right. Try to simplify it if possible. If not, that's your answer. So that's a little review for what we did like the second or the third class of the semester. We learned how to do this. The same main steps apply here. The same main steps. So we're going to find LCD and multiply all by the LCD. When we say multiply, we actually mean simplify first. And to find LCD, that's what we talked about last time when we added and subtracted rational expressions. So we know how to find LCD. And we're going to use that today to solve these rational expressions, okay? Rational equations. You can see here, it's a little unusual to see this stuff in the... Okay, so we're going to see how to... Did anybody have a question? Sorry. All right, so... Okay, so now let's see how to solve this one actual rational equation. This one has monomial here, monomial. This one has binomials. But the method, again, the main steps. So remember these two steps. Whenever you see an equation with multiple fractions, you want to get rid of the fractions first. Okay, so when you get rid of the fractions, you see the equation turns into something much easier like this to solve. So let's do that one. So 1 over x plus 2 over 3, 4 over 5x. All right, so now what we learned last time will be useful here. So we need to find the LCD, the common denominator, for all these three, x, 3, and 5x. So as we did last time, so
15.
first, that's right, first we start with the numbers. So we have 1 here, there's an invisible 1. We have 3, and we have 5. So we find the LCD for the numbers, then we're going to see what to do with the variables. So the LCD for 1, 3,
15.
that's right, is 15. That's right. Then we have variables. We have x1 and x1. Usually, if we had different powers, which one do we take again as an LCD?
The smallest one?
The smallest one, that's right. So the lower or the lowest of all if you have more.
1.
That's right.
3.
Exactly.
We got just one, yeah.
Exactly. That would
And
be
the 3. Okay.
That's right. So this is your LCD. So that's the first and the important part. Just like here, it was 15. But since we have rational expressions here, that's why we have an x. And what do we do with that LCD now?
Now we're gonna simplify.
That's right. First, we're going to put that LCD. I'm going to put it next to each fraction. So let me rewrite the equation again. I'm going to put this next to each one. So 1 over x plus 2 over 3.
Just 3.
Okay, I'm just rewriting the equation. And again, I'm just going to take this LCD and I'm just going to write it next to each fraction. You don't have to do top and bottom, okay? That you do that when you add or subtract rational expressions, not solve equations. If you have just this lights up without the equal sign, you want to add or subtract, that's when you multiply the top and the bottom by the same thing in order to get a common denominator. But here actually, we're not trying to make the denominator the same. We actually want to cancel them. So we no need to multiply top and bottom by the same thing. Let's skip that step. We actually just want to get rid of them, all of them at the same time. To do so, just put the LCD next to each one of them, and you'll see later that when we simplify, the fractions will go away, just like we did here with 15 by 5 turned into 3, 15 by 3 turned into 5, and so on. So, okay, just times, well, at least just put the LCD next to each fraction. Okay, now we're going to cancel out. So again, before multiplying, we want to cancel out this. What is 15x divided by x?
Just 15.
That's right, the x's cancel out. You have
Yeah.
15 left, times whatever number this is. Then we do the same thing over here. So 15x divided by 3 would be?
5x.
5x.
Exactly, 5x. So x stays, okay? It doesn't cancel because we don't have x here. So just 15 by 3. Bring this number here again. We'll multiply it later. Finally, over here again, we don't want to multiply yet. Let's first get rid of this fraction.
Just 3.
By 5x?
3 is
3.
That's right, so 15.
Because x is
By
gonna
5.
disappear.
That's right. Then you have x by x, those cancel out. So you don't need,
and 4.
Multiplied by 4.
let me use a different color for this. So this and this cancel out. And bring down the 4. That's already there. And that's it. That's your rational equation turned into something simpler, into a first degree equation. Pretty simple. Now we're going to multiply these. That's 15 plus 10x,
X
right? And 12.
equal 12, yeah.
And the rest is history, okay? The rest is pretty simple. Couple of steps. So you can cancel the 15 first on both sides. So that turns into 10x.
10x equal minus 15 plus 12.
That's right.
-2.
Negative. Negative what?
3.
Negative 3, yeah.
3.
Finally,
X equal minus 3 over 10.
that's right. So the 10s cancel out. So we have x. -3. Again, simplify your fraction if possible. If not, just leave it like that. And that's your answer here. This is what we call a proposed solution, by the way. It's not a solution yet. We call it proposed. That means it could or it could not be an actual solution. Why do we say so? As we talked about the other day, about the domain of each rational expression, the bottom of any fraction in general can't be 0. So for this one here, the x can't be 0. Again, because division by 0 is undefined in the group of real numbers. We don't have x here, that's fine. This is a constant. 3 will never be 0. Then again, we have 5x, the bottom. Always take the bottom of any polynomial or fraction like this, and you say that cannot be 0. Then you solve it to find the actual value of x that's undefined. Here you solve these inequalities the same way you solve equations. Just one step here. 5 divided by 5. So x again can't be 0 here. Sometimes it could be different numbers, more than just this. But in this case, so after you solve, you gotta check your solution. It cannot be one of these, the undefined values. So when you propose, when you find the proposed solution, it's not valid yet until you make sure it's not one of these. These are undefined, cannot be used, because if you plug 0 here, for example, you'll get 1 divided by 0. That's undefined. If you put that in the calculator, it will tell you error or something like that. Okay, so this is proposed, but after we checked it, that's valid. Okay, it's a valid solution because we checked it against the undefined values. As you can, we'll see sometime, even without making a mistake sometime. Let's say if we, for some reason, after solving this, we got x equals 0 as a solution. We got this solution here. Instead of this, we had this. This cannot be used as a solution because when you go back to the undefined values, we reject this. We reject it. Not because we made a mistake. There's no mistake yet. Logically, everything was done properly. But that value here cannot be used because it's undefined. Okay, so that's when you check the validity of the solution, not the regular check you do to check your answer to see if you made a mistake. You plug this here and see if it works. Now, this is a different type of check. This is a logical check to see and make sure that your proposed solution, your possible solution, is valid, not undefined. Just as in propose, when you propose, you're not sure what the outcome might be. No, for example, for marriage and stuff, when someone proposes, it's a proposition because you don't know yet. You don't know what the answer might be from the other person. So until you hear the yes or no, that's when you confirm that proposition. Okay, same thing here with stuff. That's why we call it proposed until it's checked. Once it's checked, then it's no longer proposed. It's a valid solution. And if it's not valid, if it's one of these undefined values, then you reject it and you say no solution. Again, even though there was no mistake made here. Okay, so let's put things back where they were. Let me clear this. So in this case, our solution is fine. There's nothing wrong with it. Let's see, take another example, maybe something like this with these binomials and trinomials. And you'll possibly see this, an example of this, and this will make more sense if we get a value that's undefined. The example I'm looking for is this. Basically, it's 2x over 2. Let me see the example. What is it? Right, so 2x minus 3 plus or minus actually x plus 3 here And then we have 12 over x to the second. And minus 9. Okay, so this is again a rational equation. As you can see, we have some binomials here. Again, these are our main steps. Doesn't matter the type of equation, whether it's rational or first degree, always do this. Find, if you have more than 2 fractions, find the LCD. If you have 2 fractions only, you can just cross multiply, like I said, it's easier. All right, so let's see how to find the LCD. Again, recall what we did last time. So we spent the whole class just talking about how to find the LCD of rational expressions. As always, before you find the LCD of rational expressions, what is the one thing that you need to do first? Especially here, we need to do something in order to find the LCD. What is it? Okay, just again think about what we did last time when we found
The common
Right.
factor.
okay, how well, that's right, we need to factor first.
Yes.
Here we didn't have to factor because it was just monomials. But here we have some binomials, so we're going to factor to find LCD. Again, factoring is important, especially when finding the LCD here. So factor to find the LCD. And that LCD, so let's factor this. So this is basically x minus 3. We can't factor, this is already factored. This is also factored, there's no GCF. Again, when you factor, always look for a GCF first, always. If that doesn't work, then you try other methods like a grouping. Okay, we said grouping, we talked about grouping before. You try trinomial, if it has 3 terms, and also binomial, as in this one. So this one, for example, is a binomial. What is the factored form of this?
For the minus 310?
X minus 3 plus,
For
x plus 3.
That's right. So that's what we call binomial factoring, or the difference of 2 squares, x to the second and 3 to the second. All right, now, what's the LCD now? Based on this factoring, what is the LCD? Or how do you make them all the same? So that all
3.
No, so we have, this one has x minus 3, this one has x plus 3, this one has both. So they should all be the same as this one. Okay, so this one is missing the x minus 3, so you multiply this by x minus 3, and this one is missing the x plus 3. So the LCD basically is this, x minus 3 and x plus 3. Again, we talked about this in detail in the previous lecture. You can always go back and review that video. So when you factor again, you want to make them all the same. So you think about what's missing here to look like the other ones, and you complete all of them. You complete each other until they all do look exactly the same. Okay, so that's the first step, find LCD. But here's the deal here. So last time we remember, we multiplied top and bottom by the same thing. For example, here, so this one, if we were adding or subtracting these two, we would multiply this one because it's missing x plus 3. We'd multiply x plus 3 here and x plus 3 at the top. But that's not the goal here. We want to actually not make them the same. We want to cancel them all at the same time. So that's what we're going to do, what we did earlier here. We're just going to take that LCD and basically write it next to each fraction and cancel out those fractions. So we're going to get rid of all these fractions, and the equation might turn into something simple like this without fractions, first degree or second degree equation. So find LCD. Now what we're going to do is multiply all by LCD. Again, it's always 2 main steps, these 2. So find LCD, multiply all by LCD. And when you do that, we actually mean simplify before multiplying. Before doing that, before starting to solve, let's find the undefined values here. See how we had undefined values here, x can't be 0. Let's do that here. What's the value that we can't use here? We don't want to have 0 here. So what value of x cannot be used? For this denominator, if you want to avoid having 0 in the denominator, what value of x you shouldn't use? What value of x? So we have 2 over x minus 3. Again, we can't divide by 0, so x cannot be 3 because 3 minus 0. So what you do is you just say x minus 3, whatever the denominator it is, you say can't be 0. And then you solve it. You solve this to find your the actual value. So to solve this, just like with the equations. Plus
x equal 3.
That's right, x can't be 3. So x here can't be 3. Same way here, x can't be what value?
Minus 3.
That's right, so we don't want to have minus 3 here because if you put negative 3 here plus 3, that would be 0. And again, division by 0 is undefined. So the x cannot be 3 or negative 3. Finally, the denominator, which is basically just this. So we don't want this to be 0. Also, we don't want this to be 0. So again, this one is the same as this. X can't be 3. Same thing here, x plus 3. We don't want it to be 0. That means we can't put negative 3 here. Otherwise, this would turn into 0. And the whole thing will be turned into 0. And we can't divide by 0. So x can't be 3. X can't be negative 3. Again, we talked about this with the functions when we did the domain and range. So again, the denominator can't be 0. All right, so factor first, we did. As you factor, find the undefined value. So x can't be 3, can't be negative 3. So find those first yet, right after factoring, not here. And after we solve, we're going to come back and check our solution. Okay, so going back to our step, find the LCD, we did. Now we're going to multiply all by the LCD. I'm going to rewrite the whole equation again. So this 2, 2 over x minus 3 and 12. Okay, 12 over x to the second minus 9. Instead of that, I'm going to use the factored form. That's better to, especially when you're simplifying rational expressions as we saw before. We factor first, then cancel out any common factors. Okay, so all I did was rewrite the equation here with the denominator is factored. And again, the second step is to multiply all by the LCD. This is the LCD. I'm just going to take that. I'm just going to write it next to each one of these fractions. Let me put these 2 over here. Okay, let me take this. I'm going to put it 3 times next to each one of those. Let me use a different color here. Okay, LCD. And again here, again, just like we did earlier here with this simple first degree equation, to put 15 next to each fraction. And x plus 3. Finally, third fraction, we do the same thing. All right, so now, again, we're going to simplify as we did here. 15 by 5, we got 3. Basically going to do the same thing here. So if you look at the first one here, what cancels?
X minus 3.
That's right. So this is common factor that cancels out. We end up with just 2 and this x plus 3 times x plus 3. What about the next one?
X plus 3.
That's right, the common factor cancels out, so that cancels out. And the third one, both of these will cancel out.
Both, yeah.
Right, because they're the same thing. Both cancel out, only are gonna have 12 left. So it's gonna be a minus 3, this 3, and these two cancel out, so we end up with x minus 3 left. Finally, both of these canceled out, so we had 12 left. And as you can see, once you get rid of your denominator, the equation becomes a lot easier to solve, okay, and much less intimidating. As it looked here, you can see we had all these quadratic expressions of denominator and binomials. So the rest is pretty simple. What do you do next to continue solving this?
We're gonna like open the parentheses.
That's right. We're gonna distribute
Yeah.
these and combine like terms. So 2x. So the rest from here is
Plus 6. Oh, yeah.
that's right. Plus 6 minus 3x.
Plus 9.
Right. Plus 9 and 12. Okay. Now we're gonna combine like terms. You have 2x minus 3x, which is negative 1x.
6.
And yeah,
Plus 15.
that's right. Finally, 12. Okay, come over the 15 over, or you can just subtract it from both sides.
Minus x equal minus 3.
That's right. Negative 1x equals negative 3. One final step. What do you do on both sides?
X equal 3 over, no, 1.
That's right. We're going to divide both sides by negative 3, negative 1, in order to get 3. So these two cancel out, so x is positive 3. Again, this is a proposed solution. Is this a valid solution or not? So we got this. We didn't make a mistake. No mistake was made. And we got x3. Can we take this as a solution or not? Everybody?
Yes.
Again, is this a valid solution or not? This x3. Why and why not? Everyone in the room, all 17 of you, or 16. Is this, can we take this as a solution or not? And how do you check? How do you check whether this solution is valid or not?
You just put
So you're
Plug
gonna
in the 3 for x.
put 3 instead of x.
We need to check it against some values. Which values do we need to check this against?
The first one, like the
undefined values, right? What undefined values again? We talked about earlier. X can't be 3, can't be negative. Same thing here. X can't be 3, can't be negative 3. These are undefined. Again, after you factor, you need to check the denominators. So undefined. We have x can't be negative 3. Also, x can't be 3. So after you solve, so this is our proposed solution. There was no mistake again. Can we take this as a solution? Is this a valid solution or not?
I guess no.
That's right. We said it right here. X can't be negative 3. X can't be 3. These are undefined. So if you plug this x here, you'll end up with 0. 3 minus 3 will be this 3 here. If you plug it, it will be 0 here. And 2 over 0 is not a valid, a real number. It's undefined. So we can't use that as a solution. And so proposed solution, x can't be 3 because of this, because we solved the bottoms. So therefore, no solution. No solution. Now, if you had another one, if you have another solution, then you can check it. In this case, we only had one solution. It didn't work. If you have 2 or 3 solutions, you check all of them against these. But in this case, no solution. Okay, again, doesn't mean we made a mistake here. It doesn't mean we didn't actually make any mistake here. But again, this is undefined. X can be 3. It's undefined because again, the bottom of any fraction can be 0. Okay, everybody, does that make sense?
Yep.
Yes.
Everybody else?
Yes.
Yes. All you guys, please make sure you understand. If not, please.
Yes.
Okay, so that's the whole concept or idea of rational expressions. Again, we call them rational expressions because rational equations because they're made of rational expressions. A rational expression is just a fraction that happens to have polynomials in it, binomials, trinomials, whatever. But solving them is similar to solving first-degree linear equations that we solved before. Find your LCD, multiply by the LCD. So with rational expressions, it's a little more, it's a little harder to find the LCD, but not if you factor. Okay, so we talked about this in detail in the previous class about how to find the LCD of binomials and trinomials, polynomials in general. So review that because most of the stuff we're doing now was based on that. So the only new thing here we did today was canceling those denominators. We put the LCD next to all of them, then cancel them, just like we did with simplifying rational expressions. Okay, so let's look at another problem. Let's make up another problem here. And we're gonna see, let's take maybe a more complex one this time. All right. Take a couple more examples. We're gonna do another one like this with monomials, then maybe another one like this. So let's do that. Please let me know if you have any questions at any moment. And also, of course, I'm gonna post this, so you do want to rewatch this, as many times as you need to. Okay. Luckily, we are recording everything, so you can go back to it anytime you want and watch it as many times as you need to. Let's make up something else now. Let's say 2x over, let's say, over 5 minus actually, let's make these rationals maybe here. So 3x, for example. And maybe 4/9. Okay, so we have a rational equation here. We want to solve it. What do you do first? Everybody? How do you solve, or what is the first thing you do to solve this equation?
LCD.
As always, the LCD, that's right. And that's right, the LCD is, again, we start with the numbers. We have 3, we have 6, we have 9. What do you think the LCD is for all those numbers?
3.
Not 3.
No.
6. No, it can't be 6 either. So it's not.
18, Professor.
Yeah.
No?
Yeah, 18.
18? Yeah.
Can't be 6 because they all have to go into it.
Mm-hmm.
All of these going into 18.
Okay.
That's the first part of the LCD. You want to find the number for the numbers. Then you go to the variables. We have x1. We have x1 here too. As always, which one do you take as a common? The lower power, right? If you have different powers, you take the one with the lower power. That would be the LCD. the common one. So in this case, it's just the same thing. So we're just going to take that. Good. That's the first and probably the most important step here is finding the LCD. Now, what do you do with that LCD?
So we just simplify 18
Mhm.
divided by 3, 18 divided by 6, and 9.
That's right. So we're going to take this, and we're going to try to simplify to cancel out all the fractions. Yes.
Mhm.
Yeah. You'll write your LCD next to all the fractions. And again, you don't need to multiply the top and bottom to make them the same. We don't want to do that because we want to actually cancel them because we have an equation. If this wasn't an equation, if you were just adding or subtracting fractions or rational expressions, that's when you multiply top and bottom, as we did last time, top and bottom, to make them all the same, then add them or subtract. But we're doing the opposite now. We actually want to cancel them to solve the equation. So this, now let's cancel out. So 18x by 3x would be, what is 18
6.
by 3x? Multiply and simplify. So here 18 by 3, that's 6. And x cancel out, then times these two.
12.
Plus, same thing here, let's reduce that.
3.
That's right, so it'll be 1 times 18 by 6, that's 3. And the x's cancel out.
Mm-hmm.
Finally, 4 times,
2x.
that's right. So 18 by 2 by 9 is 2. And the x stays. It doesn't cancel out because there is no x here, so 2x. And that's it. Again, you see how useful that is. The fractions are gone, all of them. The rest is pretty simple. So we have 12 here, plus 3. Over here we got 8x,
8x.
right? This is 15. 8x. We want to find x, so we're going to divide by 8. So we want to cancel 8 in this, so we're going to divide by 8. Divide by 8. X is
It's going to be negative 15 over 8 or no, negative?
not negative, but we're dividing. Okay, so we have 8x here and 15, so we divide both by 8. So 15 over 8 is the answer.
Mm-hmm.
15 over 8. X equals this or that. You can flip it if you want, but that's the same thing. Now we need, is this good? Is this valid? We need to go back and check what values are undefined here. So x can't be for this one. We don't want to have 0 here, so x can't be 0. Also here, x can't be 0. Is this a valid solution? Is this one valid or not? 15 over 8?
No,
Why not?
because x can be, okay, x can be 0. Yeah.
Okay, x equals 15 over 8. Is it okay? Is it a valid solution or not? Everybody?
I don't know. I'm struggling with that, with the last question you always ask. Like, if it's, so how you check again?
Make sure, so whatever we got, this is what we got.
Okay.
So we can't take it as a solution. It can't be one of these. These are not good. These are bad, undefined.
Mm-hmm.
These will give us 0 in the denominator. So after you solve, you check your solution. Cannot be one of these. If it's one of these, then these are not allowed. Okay, undefined, we can't use them. That's why we rejected this solution. Didn't take it because it's one of the undefined values. Undefined values means the values you can't use here for the equation. So we rejected this and we get no solution. Now, is this one a good answer or bad? Again, we just have to check it against these. Can we use this as a solution? X equals 15 over 8. Is it one of these?
No.
It's not, so?
So we can use.
You can't use it.
That's right. There's no problem.
No, I mean we can use because it's
That's right. So this one is okay.
okay.
Again, as long as it's not one of these
Mhm.
undefined values. These are bad values. Again, we can't use them. They are undefined. So after you solve, make sure it's not one of these undefined values. And again, this is something you need to do. You can't just assume it's a solution. Again, you don't have to make a mistake for this not to be a solution. There was no mistake made. For example, here, no mistake was made. We got 3. But that 3 is not a good solution. So this you have to, at the end, you have to check. You know, after you find it, you say, this is valid or not. And you can explain why. Yeah, again, this is not the typical check we do with the regular equations to see if you made a mistake. Now here, this is not about you making a mistake. It's about whether that solution is valid or not. Like I said, here logically nothing was wrong. Every step was correct, but the solution was still rejected. Not because it's wrong, but because it's invalid. Okay? It's invalid because the value 3 is undefined for this equation. Okay, everybody, does that make sense? Everyone, again,
Yes.
at the end, always again assume this is a proposal. It's not a definite solution yet. Still have to confirm, have to check it and see before we take it as a valid solution. So we have no problem with this one, it's fine. As long as it's not one of these. This one was not good because it's one of these. Let's see if we can do another one like that. Okay, so this one was not a valid solution. Let's look at another one like this with trinomials and binomials. Make it a little more complex this time. Another example, so that would be, what is it? So we're going to take, let's throw in some trinomials in the mix. X to the second plus x minus 1 over. Let me leave some space because this is going to get a lot of interesting. So minus and finally another side which happens to have trinomials as well. All right, so that looks like a complex or a difficult or intimidating equation. It doesn't have to be, as we will see, or as we saw earlier. It's a couple of steps that we need to do here, and we should solve this without a problem. But again, you need to know your factoring very well, as I always insist in every class. In addition to that, you need to know how to find the LCD here for polynomials. That's what we talked about last time in detail. So those two will be combined together in addition to the basics here of first degree equations. Combine those two in order to solve this problem. As always, what do you do first? What is the first thing here in order to solve this equation, this rational equation?
To factor the x squared plus 5x plus say 6.
That's right. So we need to factor all these in order to find the LCD. So again, factoring makes finding the LCD very easy. So factor and find the LCD. All right, so let me write the factor in here. So this is a trinomial, so we need two numbers that multiply to -4 and add up to 1. What numbers do that? +1. What numbers multiply to Let me see if I wrote this right. I believe made a mistake here. It wouldn't be possible, but it should be a 6 here. Okay, two numbers that multiply to negative 6 and add up to 1 are 2 and 3, right? But what signs? What signs? We want the multiplication to be negative, so one of them's got to be
Yeah.
negative.
-2 + 3.
-2 plus.
Right.
Yeah.
We're positive here, so the higher of the two should have the same sign as this one, B. So positive 3 minus 2. Good. Let's factor the other one quickly. What is it?
That's gonna be x minus 2, x plus 2.
That's right. It's a binomial. Difference of two squares. Again, another trinomial. What is the factor in here? What numbers?
X -2 and x + 3.
Why would you use ones?
No.
Everything here is positive.
Oh, plus, I'm sorry, so it's x + 2, x + 3.
That's right. X plus 3. Good. That's the first thing. Now we're going to try to complete each other until we find a common factor. Start with the first one here as x minus 2 and x plus 3. Let's compare it to this one first and see what is missing from this one that's already here.
X + 2.
That's right. It's missing the x plus 2. So this one's got to have that x plus 2. Okay, again, this is the equation. We're not trying to multiply top and bottom to add or subtract. We just want to find the LCD. That's the equation. We're not touching it yet. Just factor in the denominators. We're trying to make them the same. Okay, so this one, what is it missing that's here?
X + 3.
That's right. So this one needs to be x plus 3. So these are now very good. They look exactly the same. They have the same terms or factors. Now the third one needs to be like the other two as well. So what is missing in the third one?
X -2.
That's right. So this one is missing x minus 2, which these two already have. So that's x minus 2. And that's your LCD. Okay, that's the LCD here. These three factors. All right, so we found LCD. So we did this. Now we're going to take that LCD, however long it might be. We're going to take it, we're going to put it next to its fraction. It's going to be a long one here. So let me see if we can rewrite this, or I will just, okay, let me rewrite this to make things clear. I'm going to rewrite the equation, and then I'm just going to write this next to each one of those. So let me do that here. So 4x. And as I'm rewriting the equation, I'm going to rewrite it with the factor denominator. So instead of this, I'm going to use the factor denominator. That's better because we're going to see that's useful when we cancel out. So we're going to have x minus 2, x plus 3. Again, I'm just rewriting this yet. X minus 2. It's a long one, but nothing too crazy about it.
Professor, you put 2 is 3.
Here?
Yes.
Yep. These are x minus 2, x plus 2. X minus 2, x plus. Okay, I'm just rewriting this this equation first, and then I'll multiply it by the LCD. We have 2 here. And again, I'm going to use this factored form here. Oh, I see. You mean this, right? All right, let me get back to this one. Let me first write this one with x plus 2. And okay, so I just wrote the original one. Should be the exact same one here. Should be this x minus 2, x plus 3. Before the LCD, I'm just rewriting this. So actually, this is good. That's it. X minus 2, x plus 3. This one here is this before the LCD, okay? Before the LCD, just basically writing this, but with these factored out. Okay, so that's our equation, this one here. We haven't done anything yet other than factoring. Then you find the LCD, which we did. So that's our LCD. All these three. So all these three, that's the LCD. I'm going to take that. I take this LCD, I'm going to write it 3 times here. Okay, again, as simple as this. When you had 15, put it next to each one. Things are a little bigger here, but no need for this to look complex. So let's write that down. Let me see if we can, I don't know if you can copy and paste this. Probably could. All right, that's useful. Okay, so as you can see, I'm just writing my LCD next to each one of those fractions, the LCD here that we had to factor to find first. All right, what happens next, everybody?
Yeah.
The fun part, what happens now?
We can simplify.
That's right, so
Okay.
basically we're here. We just did this, we put 15, for example, here. So find, now multiply and simplify. Now we're gonna do the cross-in thing, the simplifying for each one of these. What cancels here?
X minus 2x plus 3.
That's right, it's here and here, it cancels. And plus 3 also cancels out. And we're left with 4 and x plus 2. Minus, same thing on the other fractions, our x minus 2. Those cancel out. Then x plus 2 also cancels out. So we have this one left, so 1 and x plus 3. Equal sign, finally, here, what's gonna cancel out?
X plus 2 and x plus 3.
That's right, this and this. What's left?
2 x minus 2.
That's right, this one is left. So all the mess is gone now. Okay, so your equation went from this complex stuff with trinomials and binomials and a bunch of fractions. Now it's just something as simple as this. Again, we're back to first degree equations that we solved in the beginning. So the rest is pretty simple. I'll try to do that fast here. Okay, I'm going to combine like terms here. 4x minus 1x, that's 3x. 8 minus 3, it's positive 5. And 2x minus 4. And we have x's on both sides and numbers on both sides. Again, we're going to move this over. Be 3x. As this moves over, what happens to
X
this?
Minus 2x.
That's right, the sign changes. And I'm going to move the positive 5 next to negative 4.
plus 4.
Right? This would be negative 4. X is negative 9. Again, this is a proposed solution. We need to see if it's valid or not. So to see if it's valid, you go all the way back to the factoring. Okay, if you look at the factor denominators here, what values are undefined again? So here, x can be 2. And what else? And here, x can be what?
Negative 3.
Exactly. For this one, x can be 2 again. And x can be?
Negative 2.
Very good. Negative 2. Finally, this factor here, x can be?
Negative 2.
Negative 2 and?
Negative 3.
Negative 3.
Exactly. So all these values again are not good. These are undefined. They cannot be taken as solutions. Okay, so we go back to this one. Is this okay? Is this solution here okay?
Yes.
Yes. Again, we check it against all these. The only two values that are not good are 2. So basically, you have -2, 2, and 3, or -3. So these are not good. So as long as this one is not one of these, then it's fine. So this one is proposed. We checked it. Now we can confirm it as a solution. So that's valid. Okay, so you can say valid solution. And that's how you solve rational equations. Okay, so a bunch of basically topics combined together. So you need to master each one of those. Okay, so everything adds up. So if you're lacking, if you don't know, if you're not comfortable with one of the topics or the subject used, it makes it much harder to solve the equation. So again, the main thing here is you need to know your factoring. You need to know how to find the LCD. And the basic fraction rules, you need to know those very well. And that's basically it. Any questions, everybody? What do you think?
No questions.
No.
I'm pretty sure it may still not be very clear to some of you. I understand that. You know, there's a lot of numbers here on X's. But again, just keep in mind, this is not a very complex thing. You just need to know your basic rules, like I said, for factoring and LCD and the fractions, and it's not that bad. So go back and rewatch the factoring if you still struggle with it. See how we found the LCD last time. We did a whole hour on just finding the LCD for things like these. And of course, know how to solve your basic first degree equations like that. We did in the first term. Okay, so rewatch this again as many times as needed. The more you watch it, the more sense it will make. The easier it will look. If you're not able to grasp the whole thing in one shot, always review or rewatch as needed.